Calculating a linear regression equation manually is a lot of scratch work, but none of the computations are terribly complicated. It's really just an issue of staying organized. Now let's look. Livingston Medical Service provides medical transportation. Okay, that's good. Comparing clients to actual transports for 7 courtesy van contracts, oh, that must be what these things are right here, suggests a relationship between these two issues. So here's the name of 7 contracts. It looks like it's the actual clients that Livingston Medical Services works with. How many clients are served by the contract, and how many van transports apparently last year the contract required. Now, you can see that in the note frame there's already pre-printed the 2 equations that you need to answer that question. You know, what is the linear regression equation that best expresses this relationship between the number of clients served by a contract and the actual number of van transports that Livingston Medical Service has to provide? Okay, yes, and it all involves X and Y's. Okay, so first step, don't rush anything. We have here a set of data, actually 2 sets of data, clients, van transports. The first step is let's make sure we understand which is X and which is Y. Oh, because a linear regression equation is the one straight line that best fits this scatter of XY points. The X, so to speak, would be the independent variable. The Y would be the dependent variable. One of these things we suspect depends on the other, so to speak. Oh, I see their hypothesis. The number of clients that are served is at least partially responsible for the actual number of van transports they have to provide. Okay, so that would make this the dependent variable and this one the independent variable. Independent, that's what I'm trying to write here. Okay, but more importantly, this becomes the X and this becomes the Y. And I think I see where they got their hypothesis, because do you notice for the contracts with smaller numbers of clients, like what is this, Outer Banks Services in Wilmington, North Carolina, those are also the contracts where there's only 100 some odd van transports are required, whereas big contracts, 22,000 clients, bigger number for van transport. Fine. What is the one equation that best expresses what looks like there is a relationship here? Oh, the next step might be, just to clarify, recognition of another formula that's not pre-printed in the note sheet. What's pre-printed on this note frame is a formula for B, that's the slope of the line, and a formula for A, that's the intercept. But the question is, what's the linear regression equation? Not what's the slope, what's the intercept? And we just have to remember, oh, that is Y equals A plus B times X. If you wanted to estimate how many van transports would be needed, you'd take this number plus this number times the number of clients. Yeah, and that's our means of finding that number and that number. Oh, all right, so we're closing in on it, but we still haven't done the real work yet. The real work is, well, is filling out these 2 formulas. We have to find B first. Think of it like puzzle pieces. In order to complete that formula and calculate the slope of this line, we first have to find all of the individual pieces to plug into that formula, and some of them are easy. I wanted to point this out. For instance, we need N. See that right there? N. And N here. N is easy. N is the number of contracts. Specifically in the case of Livingston Medical, N is always the number of observations in general, a little lowercase n, and it's not just linear regression. That crops up in a lot of formulas. Oh, all right, so we need this number. What is it? It's the number of contracts that we were given data on in the past data, or basically it's the length of this list. Oh, okay, so 1, 2, 3, 7. N equals 7. Okay, we have that. Now, let me get a contrasting color here. We need X bar. See that? You use it here and you use it here. That's super easy to find. X bar is just the average X. And we were just discussing the fact that what's X? X is the number of clients. So what's X bar? It's the average of those 7 numbers that we were given. The contract sizes, it's just the average of this number, that number, this number, that number, that number, that number, that number. I did that work. I get X bar equals 10,634. Okay, where'd I get that? I just averaged this. Likewise, this right here is not too hard to find. Y bar is just the average number of clients in the data that we were given. Oh, okay, so average that number, that number, that number, all through here. I get that the average number of the average number of van transports, so talking about Y, is 1,080. Oh, all right, so we have, and these numbers as puzzle pieces, like I said, they have some intuition. What is X? X is the average number of clients served by a contract in this past data. It's about 10,000. And what's Y bar? Y bar is the average number of van transports they've had to provide annually in this past data, and that's a little bit over 1,000. Oh, okay. Now, we don't have everything that we need to literally fill out the formula. You see that here we need the sigma, meaning add up the product of X and Y. Scratch work. What we need to do is multiply each client by each number of van transports and then add them all up. It would be helpful, remember I said stay organized, to move somewhere we have a little bit more room. So if you have the note frame, on the next page, there's just some room in here to do that work. Because, oh wait a minute, now, clients, this is just the numbers that we were given. In the case of the existing data, the first contract had, and the only thing I'm doing here is I am simply copying the numbers that were given. The first contract required 10,558, right? That number right there. Now, what is this particular table suggesting I'm doing? You see that the next column it says X squared? That's an X, so to speak. So this column invites me to take that number and square it. When I square it, it becomes quite large. I get 111,471,364. You can check me on that on your calculator. Okay, why did I just do that? Because another puzzle piece I need right here is the sum of X squared, meaning that I need to do that for every X in my data and then add them all up. Anyway, I just did it for one. Oh, now it says transports here. That first contract, I am just copying the data. They provided 1,042 transports. That's right there. And here it says XY. Yes, what is this number right here times this number, XY? Well, okay, I put that in my calculator. I get another large number, 11,001,436. Okay, now, why am I doing that? Because I need to complete these calculations first for, I kept circling numbers in the existing list of data for each one of these contracts in order to find these last two puzzle pieces. So, continuing on, remember there were 7? The second contract has what? 22,010 clients. I'm just copying this from the list. Oh, what is that squared? Oh goodness. 484,0,100. Very large number. Fine. Just store it. Keep it. Okay, now number of transports for the second contract. This I'm just copying over from the data, it was 2,560. Okay, why am I doing that? So that I have these two things on the same page. What is this, the x, times this, the y? Very large number. 56345,600. Huh. Or 56 million some odd. Oh, all right. Now, I need to do this for each one of the contracts. Do you see how we've now done two? Okay, so I'm going to go ahead and do that. And you can stay here with me and work along with me. Or if you think, well, I get it. I get the pattern. Okay, you could stop the video and little confidence builder, just do the other 5 on your own and then bump this ahead a bit and see if you're getting the same conclusion that I was. Either way works. Okay, because continuing on, I'm looking at the original data and it says in the third contract there were 2,455 clients. Okay, if I square that number, I get what? 6,027,025. Okay, store that number. Now looking at the data, the third contract, there wasn't a lot of transports. There was only 149. So I say that times that, and I get 365,795. Okay, fourth contract, just the data. 1,405 clients, according to the information we were given. Square that. All right, 1,974,025. Okay, number of transports from the data. Well, that was just 186 for the fourth contract. Fine, what is this number, the x, times this number, the y? I get 261,330. Fifth contract, 12,400 clients. Square that number. 12,400 times 12,400, 153,760,000. Okay, number of transports under that contract, 292. Fine, that number times this number, what is it? I get 3620800. All right, sixth contract. Well, there's only 5,410 clients. 10. Whoops, there's supposed to be a 1 in there. 410. Square that number. Okay, 229,268,100. Okay, now the sixth contract, how many transports? 1,128. This number times that number, I get 6102480. All right, last contract, clients, lots of them, 20,200. Last contract, take that number and square it, stand by, really big number, 408,040,000. Last contract, how many transports? From the data, 2,203. Last calculation, or subcalculation, what is this number times that number? X times Y. I get, okay, 445,006,000. And I had said last subcalculation. All right, now we've done it for all 7. Why were we doing this? I mean, what was this for? Because we needed to know, for instance, the sum, sigma means add up, sum of x squared means add up all these numbers now that we've found them. That is a really big number. 1,194,980,614. It's just the sum of all of these numbers. We needed that number for our formula, and we also need this number, the sum of x times y. The sum of x times y, yeah. All these numbers we worked so hard for, just add them up. Okay. 1, 2, 2, 1, 9, 8, 0, 4, 1. Oh, great. Now we have those two numbers. Now what are we supposed to do? Now we're actually ready to complete the two formulas that we could see at the very beginning in this no frame. Because now that we have those two numbers, right? We want to find the slope and the intercept. Slope B equals, okay, what was the absolute really, really large number? 1, 2, 2, 1, 9, 8, 0, 4, 1, right? That was the sum of x times y. Now, minus, I'm just filling out this formula up here. N is 7 times x bar is the average x. Well, that's that number right there. 10,634. Y bar is the average y. Well, that's that number right there. 1,080. Okay, so you multiply all those things together and subtract it out of that. That's just the numerator taken care of. Divided by the sum of x squared. Oh, that's that other really large number, the 1 billion. 1,194,980,614, the number we just found, minus, that n is a 7, times, now this is x bar squared, meaning the average x, 10,634, except square it. Then multiply it times the 7, subtract that out of that huge number, right? Divide that into that. You're just filling out the formula, and you come to this conclusion, and it looks pretty puny compared to all that. 0.10363. Oh, what's that supposed to mean? Well, we found it. We found the slope. Oh, we found the slope of the linear regression equation. You know, like that's what we're after. Okay, now that you have the slope, you can find the intercept pretty easily, because see how the intercept is just a equals average y. Okay, well that was 1,080 minus, you need the number from over here, or that number right there, 0.10363 times the average x, or that number right there, 10634. And that's pretty much almost exactly -22. And I keep putting boxes around those numbers like, ta-da, that's the answer. But we do always have to remember, well, what did they ask? They asked, what's the linear regression equation that describes this relationship between clients and van transport? Really, to answer that question, we want to specify. The answer is y, right? The number of van transports we think equals -22, that's the A, plus 0.10363, that's the B, times x. That's the actual linear regression equation that we just found manually from that data. Oh, now wait. There's a follow-up question on that, but it's not nearly as much work as actually just finding the regression equation. We found the regression equation. There's a follow-up question here in this scenario asking you to basically use it. I mean, it's meant to be a tool. What's it say? Oh, it's over here. We kind of whisked away from it, right? There were our sub-computations. We went back to the original formulas, but here on the second sheet, it says, what does this suggest the annual demand for courtesy van transports would be for a potential contract, right? What would they use this equation for? Now, summarizing what I just wrote, this is the regression equation that we worked so hard to get. Okay, clients predicts van transports. They want us to predict van transports for a contract with 2,100 clients. Do you see how we use this? We just say, all right, fine. negative 22 plus 0.10363 times, put the 2100 here, 2100. I did that and I got, this equals, it's kind of messy, 195.621, of which there's no such thing as that many van transports. So basically, if you were reporting to Livingston Medical, you'd say, well, you know, based on this analysis, we would estimate that there'd be about 196 annual van transports from that contract with 2,100 clients. Or another way, you notice how this particular regression equation is working? Another way to think about it is it looks like the number of van transport annually is about 10%, the number of clients served by the contract, because that is the meaning of the slope of this particular linear regression equation.